OpenAI just quietly released something potentially game-changing to their pro users. GPT-5.3-Codex-Spark, a research preview of the first model designed for real-time coding. It's smaller than regular Codex, but it delivers over 1,000 tokens per second on specialized Cerebras hardware, and the answers you get are almost instantaneous. For years, we've been getting better models, and now they're betting on a different dimension. Latency and speed matter as much as overall capability. Their frontier models can work autonomously for hours or days, where Spark works with you in the moment. Today, I'm showing you what the speed unlocks and when would you use it instead of the full model, and what this research preview tells us about where AI coding is headed in the future. So now let's try to use it in practice. Right here, I have my Pro account with GPT-5.3-Codex-Spark selected. I've built a pretty long prompt to test its capabilities in building a game. I will be able to share this prompt in the description if you'd like to check it out, but the thing I'm most interested in is not if it will make it, but how fast. So let's submit the prompt and see what it does. And wow, it's already done. It built it in 49 seconds, and I'm actually curious if it's gonna work. So let's go ahead and try to play the game. So I see the first game screen. It tells me to press enter to start. Let's do that. And I can already see the controls are working. I can walk around with WASD keys. And the prompt was that I asked it to build a game where I could walk around and eat apples. And it should give me a 60-second countdown for the leaderboard. And I see the time running at the top right. And as I eat apples, my player should get bigger. I even see it incorporated combos, which I didn't ask it to do, but it's a very nice touch. And keep in mind, this is an only prompt that I asked it to do. I didn't give any follow-ups or steering. And now I have 20 seconds left. My score is 33. I see that the bigger apples give me a better score. So let's try to get as many as possible. Time's running out. And that's it. All right, we got 23 apples. Let me say my name, Thomas. There's a leaderboard. I'm first in place, given I'm the only player, but it works. It actually did what we asked it to do, and that's the amazing part. It only took 49 seconds to incorporate that. And the thing I'm curious about is how the regular codex would perform and what the output would be, and most importantly, the speed. So let's look into that. I just created a new project in Codex. I'm gonna go ahead and choose GPT 5.3 Codex, paste in the same prompt I used for the Spark, and now let's see how it performs. And while Codex is working, I want to remind you, subscribe to the channel of Turing College for more videos on the latest AI industry news and developments. I see it is taking the same steps that the Spark did. It is looking at the directory. I gave it an empty folder to start with. Note that my 5.3 Codex is now on extra high reasoning, meaning it is expected to think for longer than the Spark one. But the question is, how much longer, and is the output gonna be very different? And while GPT 5.3 Codex is working, I can tell you a little bit what makes Spark possible. It's a result of their partnership with Cerebras. They only started working a couple of months back, and the speed of innovation shows how crazy AI is these days. Spark is built fully around speed, meaning it only does targeted and small edits and doesn't do anything you don't ask it to. For example, if you wanted to do any tests, you have to say that explicitly. Codex is still working. It's been 6 minutes. I cannot believe that Spark did it in under 50 seconds. But I see it's actually giving me the final touches. Codex did the task in 6 minutes and 18 seconds. Again, while Spark used the same prompt and had a result in 49 seconds. Now, let's compare the outputs of both models. Let me open the game that GPT 5.3 Codex built, and we already see it has much more detail. But again, it tells me to press enter to start. Let's try that out. I can use my keyboard to walk around. I see one apple, +1. I see another one. So I'm collecting the score very slowly. but I see all of the same functionality that we had with Spark. So I'm walking around trying to collect apples. The first thing I noticed, I only managed to get 4, and it has way fewer apples than the Spark game did. I only have 10 seconds left, so I better hurry up. I see a couple more. I see it also implemented combo. That's a nice touch. And we have a couple seconds running. That's it. All right, I got 11, so a much lower score. Let me add Thomas, submit my score, and I'm on the leaderboard right now. And the first thing I noticed is that the Codex game, it has much more detail. For example, this leaderboard definitely looks much nicer than the one that Spark did. However, the game I played with Spark was much more engaging for me. It had much more apples to play with. Having 2 games compared side by side, I can now confidently say that if you need much more detail in your game or in your task, you still should choose 5.3 Codex. As we can see, the dashboard is much nicer, the UI is much more beautiful, and with extra prompting, you can definitely reach better results. However, we cannot neglect the fact that Spark did the task in staggering 49 seconds. And that is incredibly fast. If you're working with your team on the spot, Spark is probably the way to go. You will see very quick results, you can prototype quickly, and when you need some polishing, you will switch back to Codex. So there you have it, a comparison between Codex and Codex-Spark. And the best way to wrap this up, I think, is to quote one of the engineers in the Codex team. In his very own words, it is very cool to see a research preview of something that will be mainstream in a couple of months. See you in the next video.